Okay, so we're going to first start by the chart of the in behavior. And we're going to be using these terms as x approaches negative infinity, what's y going to be doing? Y is going to be approaching either positive infinity or negative infinity. So when you have the n is your degree, this should be a sub n. And the a sub n is your leading coefficient. So when the n is even, the y values of the graphs are going to be going in the same direction in the y direction. Okay, so they're both going to be going up, like in this case, or they're both going to be going down, like in this case. When the degree is odd, they're going to be going in opposite directions, and if it's a positive leading coefficient, that means it's going to be going from a negative position to a positive. And when it's a negative with an odd degree, it's going into a negative direction, so from a positive direction to a negative direction. An example of this would be something like this. So as the x value is approaching negative infinity, which means as the graph is going to the left, what's the y doing? The y is approaching positive infinity. As the x value approaches positive infinity, what's the y value doing? Well, the y value is approaching positive infinity. And that's what all of that means. You can still think of it as the up and up, down and down, down and up, all that stuff, but do understand these terminology and what they mean. Okay, so for this first problem, we're going to find the polynomial of degree 7, whose zeros are negative 2 with the multiplicity of 2, 0 with the multiplicity of 4, and 1 with the multiplicity of 1. Well, remember, I'm given this as a 0, which means I can write it in the factored form x minus the 0, so that's going to become x plus 2. It's a multiplicity of 2, so it's going to be squared. This is going to be a 0, which is just x. X minus 0 is going to be 0. So is going to be x, so it's going to be x to the 4th, and I'm going to write that out in front. And then this one is going to be x minus 1, so that's going to go here. And if you're writing it in standard form, I got to do my exponents first, so I'm going to square that x plus 2, and that's going to become x squared plus 4x plus 4, and that's going to be multiplied with x minus 1. Now I'm going to multiply these two first. So I'm going to be left with, I've still got that x to the 4th out in front. And I have x to the 3rd minus x squared. Now I'm going to distribute this 4x, and that's going to be plus 4x squared minus 4x. Now I'm going to multiply this 4. So I have plus 4x minus 4. I'm going to simplify all this first. I still got that x to the 4th out in front, so that's going to be x to the 3rd. These two combine to be positive 3x squared. These cancel out, minus 4, and I'm going to distribute the x to the 4th now, so that becomes x to the 7th plus 3x to the 6th minus 4x to the 4th. We're going to look at what the multiplicities do from a graph standpoint. So I'm going to have 3 graphs. Okay, the A is going to be with a multiplicity of 2. the b is going to be with the multiplicity of 3, and the c is going to be what the graph looks like when there's a multiplicity of 4. So when there's a multiplicity of 2, what happens is that it touches the point of the 0, but then it turns and it doesn't go through it. Okay, so if I had a 0 here and it was a multiplicity of 2, what it does, it kind of does like a quadratic, and it touches that point but then turns. And that would be a multiplicity of 2 if it does that at the 0. A multiplicity of 3 goes through the point, but it kind of has that like cubic turn. So what happens is it will make that turn right at the point, and what that means is there's a multiplicity of 3 at that 0. And the multiplicity of 4 looks very similar to this one here, except it's going to be a little bit more flat. It's going to look something like that. And it's just a little bit flatter down there at the bottom. Okay, so we're going to have to sketch this by hand. So what we're first going to do is find the zeros from this function. And I know I have zeros of x equals -2, and it's +1 with the multiplicity of 2. The y-intercept will be helpful, and what I'm going to do to find the y-intercept is plug 0 in for the x's, and so I have 0 plus 2 is 2, 0 minus 1 is -1, -1 squared is 1, times 2 is 2. So my y-intercept is 2. I'm going to put that on there. My x-intercepts are -2 and +1. Remember, there's a multiplicity there. And then the number of turns it's going to make, the number of turns I didn't write earlier. To find the number of turns, we'll write it now, is going to be n minus 1, the degree minus 1. Well, the degree here is actually x to the third, because this is my quadratic times the linear. I'm going to have an x to the third, and it's going to be a 1x to the third, positive 1x to the third. So the number of turns is going to be 2, and the end behavior, because it's a +1, it's going to be going in a positive direction. So as x is going to the left, the graph is going down towards -infinity, and then when x is going to the right, the graph is going to be going up towards +infinity. So what I'm going to do is draw my arrows for my end behavior there, and then connect them through the points that I already have. And remember, because there's this multiplicity here, what happens is that it touches it but then turns around and goes back. Remember, this isn't an exact graph, it's a sketch. Okay, this point here should actually be further up, but we're not going to find that. I'm just going to be asking you to draw a quick sketch of it, including those parts. So here's another one. In order to find all those parts here, this should be x to the third there. I'm going to have to factor it. So I'm first going to factor out a -x cubed. I have left with x squared plus 4x minus 5, and then that factors into x plus 5, x minus 1. So my zeros are going to be 0 with multiplicity of 3, -5 and positive 1. My y-intercept, if I plug in 0, I get 0 here, 0 here, 0 here. So my y-intercept is 0. My number of turns, or turning points, this is a 5th degree, so there's going to be 4 turns. And then my end behavior, because it's odd, they're going to be going different directions. And the coefficient is a negative, so it's going in a negative direction. It's coming from positive down to negative. So I'm going to plot my zeros. That's my 0 and y-intercept there. -5. I draw another point there, and positive 1. And then my arrows from this point, it's going to be going this way. What happens at this part, because it's a multiplicity of 3, it kind of has that cubic turn like that. I'm going to try to draw it as best I can. And then goes back down through that last 0. So that's a sketch again of the graph, what it's going to look like. Just know that this cubic turn right here is actually 2 turns. So there's 1 here, 2 here, so that's 3, and then another one there to go back down. So in order to write the functions, I'm going to need to look at this graph and tell the zeros. And I have zeros of -3, -1, and positive 1, but at positive 1, because it makes that turn, it's a multiplicity of 2. So I'm going to have x plus 3 times x plus 1 times x minus 1 squared, and that's going to be my function. And that's it for today. That's all I'm going to go over. The assignment's up on the website. You can check that.